In the previous video, we talked about how to use TensorBoard to visualize computational graphs and how to manage multiple graphs in one program. In this video, let's spend some time to talk about some basic data structures in TensorFlow, which are tensors and variables. So if you have a background in mathematics or physics, the word tensor probably has a very specific meanings to you. But in TensorFlow, a tensor is merely a data structure for representing homogeneous multidimensional arrays. So homogeneous means that every element inside of the array must be of the same data type. So they must be all integers, or floats, or complex numbers, or strings, or anything, right? Any kind of object. The elements in the same array cannot have different data types, which means a tensor is basically just a homogeneous multidimensional array. If you have used NumPy before, NumPy, it's also a Python module that's kind of very popular for linear algebra and matrix or array-based operations, right? And in fact, Python's TensorFlow's Python interface is very much built upon the NumPy module, actually. So if you have used NumPy before, the tensor in TensorFlow is actually very similar to the ND array in NumPy. Right? If you haven't heard about it, it's called ND array. And in fact, the tensor, the Python API, the Python interface of TensorFlow is actually the tensor implementation of TensorFlow is actually built upon this ND array in NumPy, actually. So they are actually very similar. The number of dimensions of a tensor is called the rank. So a rank 0 tensor is just a scalar. And then a rank 1 tensor is basically just a one-dimensional array. And then a rank 2 tensor is basically just a two-dimensional matrix. A rank 3 tensor is just multiple matrices stacked into a cube, basically. It's a data cube. And we can also have tensors with even higher ranks, right? A rank 4 tensor, rank 5 tensor. It's, they use the word tensor in a sense that that's kind of detached from its physical meanings. In terms of if you actually have a physics background, right? Any kind of physics, mechanics, quantum mechanics, general relativity. They also use the concept of tensor quite extensively, but here in TensorFlow, it actually means completely different thing. It just means a homogeneous multi-dimensional array, basically. Right. So now let's look at some rank 0 tensors. So in this video, we're just going to deal with rank 0 tensors and variables. So the first thing we're going to do is to import the TensorFlow module, right? Import TensorFlow as TF. Right? And when we are experimenting with our code, we may have to run the same code many times, right? But the default graph may not be all cleaned up from the memory every time we run the code. So as a result, we may end up with a default graph containing many duplicate nodes after multiple experimental runs. So TensorFlow provides a function to reset the default graph whenever we want to start all over again from scratch, from a clean slate. Right? We can enforce a reset of the default graph sort of at the start of our program. We can just call the reset default graph. We can just call this particular function so that the default graph is all cleaned up for us when we actually start to run our code. And now let's create a rank 0 tensor with a value, with a constant value of 3. So let's just call it W. W equals to tf.constant 3, right? Let's just give an arbitrary value 3. And we can run this part of the code. It's very simple, right? And then we're gonna get in the variable explorer. If you are using a console to run this piece of code directly, then you may not have the variable explorer. If that's the case, you can just type W, right? And then it's gonna tell you it's a tensor, right? So here it's a tensor. It's a tensor. In the variable explorer, it's a tensor. We cannot really get the value inside of W yet, because the graph has not been evaluated inside of a session yet. For now, we are still just building the graph. We haven't actually evaluated or executed the graph yet. So for now, we cannot really get the value out of W yet. Even though we know it's a constant of 3, right? But in the program, in our program, we cannot actually fetch the value yet. And we can define another tensor x that depends upon the tensor W. So x is going to equal to W plus 2. Right, here we have defined another tensor x. If you don't believe me, x does have a type of tensor, right? And x depends upon W, right? So here we are not really doing the evaluation. We're not really doing the summation yet. We're not doing the addition, right? It's just defining another tensor x. The evaluation is going to be carried out when we execute the graph. Here we're just building the graph. And we can define 2 more tensors. Let's just use y equals to x plus 5, right? And then z equals to x multiplies 3. Again, x, y, and z are just nodes on the graph. W, x, y, and z is just 4 different nodes on the graph, right? So all those calculations haven't been carried out yet because we haven't actually run the graph yet. Let's just run it and see. They are all tensors. The 4 variables. No, not the variable. The 4 names W, X, Y, and Z are all tensors. And now let's start a session to evaluate Y and Z. So we're gonna start a session here using with as right, and then so the simplest way to actually fetch the value assigned to a tensor is by calling the eval method on the tensor, right? So both y and z are tensors, right? So one of the methods that's defined on the tensor object is called eval, and the easiest way to actually fetch the value that's inside of the tensor is by calling the eval method, and the eval method is going to return the value, that the content that's stored in the tensor as a NumPy array. Right, so what's actually being returned by the eval method is actually a NumPy array. We haven't talked about NumPy in detail, right? We just know it's an external library. It's an external module, right? But we haven't talked about NumPy. Right? What I'm telling you is that the eval method is going to return a NumPy array, and this print function can automatically display a NumPy array. Right? A NumPy array is just like a Python list, but it has more capabilities than the Python list. So if we try, let's just run it, and we're going to see the 2 outputs, 10 and 15. So y is going to have a value of 10, and z is going to have a value of 15. Is that right? Because w is initialized to 3, right? So x equals to w plus 2. 3 plus 2, that's 5. And y equals to x plus 5. So x is 5. 5 plus 5, that's 10. That's 10, right? And then z equals to x multiplies 3. 5 multiplies 3, that's 15. So the calculation was correct. If we try to call this eval method without the active session here, then we're gonna get some error message. Let me comment out of this part of the code, right? And then let's just call maybe y.eval, right? And let's just let me do a reset -f here. Let me just rerun it, and then it's gonna give you an error message. It says cannot evaluate tensor using eval. No default session is registered, right? So it's telling you there's no active session for doing the evaluation. So this eval, when you call this eval method, you must make sure that you are inside of the active session. There is an active session that allows you to do this eval, right? So right, this time let's run it again. So it's producing the right result. When we actually try to evaluate a node on the graph, for example here, right, when we try to do this evaluation for the tensor y, TensorFlow automatically determines the set of nodes that it depends upon, and it will evaluate all those nodes first. So when we try to evaluate y, TensorFlow automatically detects that y depends upon x, right? Y depends upon x, and x depends upon w, right? So it first evaluates w, and then x, and then y, and then returns the value of y. And when we try to evaluate z, TensorFlow detects that it must first evaluate w, and then x, and it's gonna reevaluate both w and x. It's just gonna forget about it has already evaluated w and x when it actually try to get the value for y. So the important thing for us to realize that TensorFlow will not reuse the w and x values that it has already evaluated when computing the value for y. So this code, these two prints inside of the session, will actually evaluate both w and x twice. Every time we evaluate a node, it is called a graph run. And all the node values are dropped or wiped out between graph runs. The reason is that tensors by themselves are actually immutable, which means that once they are created, the values stored in them cannot be modified. We can only destroy a tensor by assigning the same name to a different tensor. And different graph runs may involve different initial values. Here w is initialized to a constant, so every time I run it, it's going to have the same value, right? But suppose I initialize w with a random number, right, which can be different for different runs. So the default behavior of TensorFlow is to wipe out clean all previous node values for every graph run. So if we want to actually improve efficiency, if we want to avoid evaluating both w and x twice, so how can we actually do that, right? How can we actually do that? Right? We can try to evaluate both y and z in just one graph run. Right? If we can do that, then w and x are evaluated only once, right? So here we are evaluating y and z by calling the eval method on y and z separately, right? But we can actually do that by calling the session's run method. So y val, we're defining an integer, z val is going to equal to ses.run. We're just calling the run method, and the run method takes a takes an input that's called a fetch, and we're gonna fetch two things, y and z, right? We're gonna, oh no, it's actually one thing, it's a list, right? We're actually giving the run a fetch that's a list, and this list contains two tensors, y and z. And this sys.run is gonna do just a one graph run. It's gonna do just a one graph run. And during that one graph run, it's gonna evaluate both y and z. And then it's gonna return the result as a tuple, as a Python tuple. And here, during this assignment, there is a tuple unpacking or sequence unpacking. The two numbers in the Python tuple is assigned to y val and z val. And at this point, we can just print out y val and z val. We're gonna still do like two prints, even though we can actually, both y val and z val are just the ints. We can actually put the two ints in the same print statement, print function, but let's still do it separately because it makes it easier for us to do the comparison. 1015 and 1015. The result is the same, but we have saved one graph run and saved one set of evaluations for w and x. Right? So that's sort of the default behavior for tensors inside of the for tensors among different graph runs, right? And all the node values are going to be dropped for the tensors during between different graph runs. But sometimes we do need to maintain node values across different graph runs. One example is the weights used in the neural network. In fact, during the training process, all the weights obtained from the previous iteration must be maintained. The value of the weights obtained from the previous iteration must be maintained so that we can make successive modifications to those weights. So in practice, we do need to actually maintain those node values across different graph runs. In some situations, for some kind of for certain data, right? And TensorFlow provides a special kind of tensor called variables for this kind of purpose. So unlike ordinary tensors that are only instantiated when a graph is run and are all wiped out clean afterwards, TensorFlow variables survive across multiple graph runs within the same session. So TensorFlow variables will not survive across multiple sessions. If we close the session in which the variables are initialized and open a new session, we must remember to reinitialize all the variables before using them in graph runs. We actually have seen TensorFlow variables in the previous video. So in the previous video, we're actually using TensorFlow variables. But in the previous video, we didn't actually explain the details, right? In fact, there are two different ways to define a variable. One is to call the variable constructor. A variable is an object, so it's got a constructor, right? That's the technique that we used in the previous video, right? And another way for constructing a variable, or for defining a variable, is to call the getVariable function and provide a mandatory variable name, and then an optional initializer value. So here we're gonna use the getVariable method, getVariable function actually. So before doing that, let's do a reset of the graph. We're gonna do a reset on the graph. We're gonna clean up the graph, and then we're gonna define a variable that's called w1, and this time we're gonna use the tf.getVariable method, and the first input is actually a mandatory variable name. Let's just call it w1, right? And then it takes an optional input that's called initializer. the initializer value can be an ordinary tensor, and here we're gonna use a rank 0 tensor with a value of 3. So we're gonna just construct this ordinary tensor on the fly using the TF constant method, and that's gonna be our W1. And the recommended way for creating variables among the two different ways, one is called the get variable method, the other one is by using the constructor, variable constructor here. It's the recommended way is actually to use get a variable function, and we will gradually understand the reasons in future videos. And if we run this code, we're gonna see, where's my x1? No, where's my w1? W1 has a type of variable. It's not a tensor anymore. It's actually a variable now, right? Now it's a variable. Right? If we want to use a variable's value when initializing another variable, we must call the initialized value method. So we cannot just use the variable by itself. We have to actually call a specific method on that variable. So suppose I want to define a new variable that's called x1. Let's give it a name x1, right? So for the initializer of x1, I want to use the value that's stored in w1 to initialize x1. So how am I supposed to do that, right? I must call w1 dot initialize the value. It's a method defined on a variable, and then plus 2. So you can sort of see here, I'm not just using w1 here, right? You cannot use w1. If you are using w1, you may not get the same. You may not get the correct behavior. The reason is because when you try to initialize x1 after you have opened up the session, right? Your initialization for variables must happen after you have an active session, right? In the previous video, we actually sort of did that already, but today we're going to emphasize that you must initialize it. You must explicitly initialize all the variables. Right? When you actually do this kind of initialization, w1, x1, all those variables do not yet have values in them yet, right? And this kind of initialization process is somehow random. You don't really know which variable gets initialized first, right? By calling this method on w1, you are saying that w1 has to be initialized first before x1 can be initialized, because x1 must use the initialized value of w1. So if you do not do that, just put a w1 here, right? What if x1 gets initialized before w1, right? At that time, w1 doesn't have a value in it yet. Doesn't have a meaningful value in it yet. Maybe it was initialized to some kind of random number, right? So you have to remember to call the initialized value method on w1 if you want to use the w1's value to initialize x1, right? And we can actually repeat the same process for two more variables. Let's define y1 equals to tf dot get variable. Let's just give it initializer equals to it's supposed to be x1 dot initialize value plus 2, plus 5, I think. Plus 5, right? So basically, we're actually just repeating the same calculations that we did using ordinary tensors by using variables now. So z1 equals to tf dot get variable. Let's just call it z1, and then equals to x1 dot initialized value times 3, right? And now we can open a new session and do some graph runs. So with tf dot session as says, right? So but before the graph is executed for the first time, every variable must be explicitly initialized, either by calling the initializer on each of the variables, like what we did in the comment code in the previous video, right? We're calling the run method on the initializer of each of the variables, right? That's one of the ways of initializing variables, right? But if we have lots of variables, then we can actually do the initialization in a batch mode by calling this particular function, global variables initializer. Then it's going to initialize all variables, right? So here we're going to use the second method. We're going to use sysrun global variables initializer. Right. In the previous video, we're actually defining an operation that's called init, right? And then we're calling the init.run inside of the session. But here we're just using sys.run to run this operation directly, right? And so this particular function, the global underscore variables underscore initializer, is going to return an operation. An operation is also an object inside of TensorFlow. And we'll talk about operations in a lot more detail in later videos. And now we can actually do two separate graph runs now, right? So let's do print y1.eval. Don't forget, a variable is also a special kind of tensor, right? For every tensor, you have the eval method to actually fetch the value that's inside of that tensor, right? So y1 is a variable, so it also has the eval method defined on it. And then print z1.eval. And then this time let's just run it. So 1015, 1015, and the results are identical. And now we can do two separate graph runs without re-evaluating x1 and w1 twice. Right? And x1, w1 will actually maintain their values across these two different graph runs.